So, like I said, 7-1 is about permutations and combinations, and this is going to start our probability unit. We are going to use the fundamental counting principle and use permutations and combinations today. So I asked you how many outfits can be made from 6 shirts, 3 pants, and 2 necklaces. One thing that your textbook covers is how to do this using like a tree. So you have 6 different shirts, and then each shirt, I'm just gonna put ... has 3 different pant options. 1, 2, 3. I'm gonna call them A, B, C. And then each pant option has 2 necklaces. I'll write these in Roman numerals. 1 and 2, 1 and 2, 1 and 2. So for one shirt, how many different outfits could you make? 6. And if you have 6 different shirts, you can think of it as 6 multiplied by 6, which is 36. Okay, you can also use the fundamental counting principle, which I heard that some of you did, where you can multiply them all together. So if you have 6 shirts, you can multiply that by the number of pants you have times the number of necklaces. 6 times 3 is 18. 18 times 2 is 36. That is the fundamental counting principle. So you guys did a good job. All right, now for example 1, we're going to use this fundamental counting principle to figure out how many Sunday choices there are. And you have a little table here to help you figure out your options. So to make a frozen yogurt sundae for $2.99, you choose 1 flavor of yogurt, 1 syrup, 1 topping, and then you have to figure out how many Sunday choices there are. So we're going to assess how many flavors there are. How many flavors are there of yogurt? 3. Chocolate, vanilla, strawberry. Okay. And then Max, how many different syrup options do I have? 4. Yep. Caramel fudge, strawberry, peanut butter. And then Joe, how many topping choices do I have? 4. 3 times 4 is 12. 12 times 4 is 48. So then there are 48 sundaes that you can make. All right, so that is your fundamental counting principle. For example 2, we are going to get into some passwords. Now, a password for this site is going to consist of 4 digits followed by 2 letters. But there's some specifications here. And that's that you cannot use the letter A and Z. We are assuming here that your letters are not case sensitive. So they don't say that, so they're just going to be the capital letters. Okay? And then each digit or letter can be used more than once. And we have to figure out how many unique passwords are possible. So unique means not the same. Okay, so how many different ones are possible? So we are going to end up multiplying, but then let's think of how many options there are. One thing I like to do whenever I have like a password, it's 4 digits. So I would say, okay, this has to be a digit, a digit, a digit, a digit, and then it's followed by 2 letters. So this has to be some letter, this has to be some letter. Okay, so a digit, a digit, a digit, a digit, a letter, a letter. So let's figure out how many options there are. So then will you guys think about how many options there are for the digit and then how many options there are for the letter? Okay, how many digits do you guys think there are?
10.
Yes. Why is there 10? 0. Okay, so your digits are 0 to 9, so there are 10 options. Okay, the alphabet has how many letters?
26. 26. That's still not 22. 26 minus 2 is still not 22.
Okay, so if you can't use A or Z, then you have 24 options. You can repeat these. So for the digits, I can use any 10 for the first, any 10 for the second, same thing with the third and the fourth, and then for the letter, I have 24 options for both of those. Okay, so to find how many possible passwords, I'm just going to multiply those all together. Right? When you multiply, you can also do, remember that that is 10 to the fourth times 26 squared. So you can plug it in like that.
26.
Oh, thank you. It's like, what? Squared. Okay, so then, how many passwords did you guys get?
5,760,000.
Yes, 5,760,000 different passwords. Yes. Okay, now for part B, it says, what if you couldn't repeat digits or letters for part A? And then keep in mind too, when we did this without even thinking of it as being case sensitive. Case sensitive would mean you'd have how many options here?
So many.
You'd have 48, right? Okay, because you'd have all the lowercase letters too. Let's see what that would be. If we did 10 to the fourth times 48 squared.
That's used a lot.
Whoa. 23 million? Well, that is a finite number.
They have a program that does it all.
Okay, so what if you couldn't repeat digits or letters for part A? Then how many unique passwords would be possible? So how is this going to change what I'm multiplying? So if they can't repeat it.
It'd be 1097.
Right, so you have all the options for the first one, but then whatever you use there wouldn't be an option for the second digit. So there'd only be 9 possibilities. And then those two wouldn't be options, so then you'd only have 8. Then you'd have 7. Okay, and again, those are your digits. And then for your letters, you would have all options for the first one, but then only 23 for the second one. Okay, so then you would multiply those together. Yeah, have you guys done factorials before?
I know what they are.
Isn't it just like the 9
It's
to
all the whole numbers
Yeah.
below.
Let's go. Because
Okay, so obviously here, if we're putting restrictions on it, if we don't have as many options, we would expect there to be less passwords, right, than we had when we could repeat them. Can't put that away, pay attention up here. Your factorial is going to be the product of the natural numbers. So product means multiply. Natural numbers are what? What else? Yep. So natural numbers are often called the counting numbers because when you start counting, you usually start with what? 1. Okay, so yep, 1, 2, 3. So let's do some examples. So this is factorial. You probably have seen the exclamation point. So the factorial is an exclamation point symbol. So if something asks you to evaluate for 4 factorial, that means you would do 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. Obviously, anything times 1 is itself. Okay, so then if we did 6 factorial, we would do 6 times 5 times 4 times 3 times 2 times 1. And then you also have a factorial button on your calculator. I'm going to show you where that is. Okay, so if you type in 6, we're going to do 6 factorial. And then you go to math, which is the third button here. You're going to arrow over to where it says PRB. Because what does PRB stand for? Probability.
Probability.
Okay, and then you have the exclamation point here. Okay, and and then that's gonna give you 720, which is exactly what you would get if you multiplied. Obviously, when we're multiplying, I never do the times 1 because we know times 1 is gonna be the same thing. Okay, so now let's find what 0 factorial is. So 0 is special. So if I do 0 factorial, it is gonna be 1. Okay? Well, it's because you're multiplying. So because you are multiplying in your factorial, if you had 0, that would change the value. But if you have 1, it's gonna keep it the same. So basically, in order for you to apply 0 factorial, you'd have to multiply by 1, so you wouldn't change the value of it. So I know that is kind of different. Okay, so if we're gonna evaluate, we're gonna do part of this without our calculator so that we can start to recognize some of the patterns here. So if you have 3 factorial over 2 factorial, that's like 3 times 2 times 1 over 2 times 1, and really what happens? Yeah, the 2's and the 1's are gonna cancel, and you would just be left with 3. So you can also think of this as 3 times 2 factorial, right? Over 2 factorial, those cancel, you're left with 3. So when we're thinking about part B, if we are to write out 9 times 8 times 7, and then 6 factorial for 9 factorial, right? 9 factorial is 9 times 8 times 7 times 6 factorial times 2 factorial over 6. Then these are going to cancel, and I'm left with 9 times 8 times 7 times 2, right? Or 2 times 1. So then we can use our calculator for that part. 9 times 8 times 7 times 2. You get 1008. Okay. Now for C and D, you do have some different parentheses here. If the 6 minus 2 is inside parentheses, you're going to do that part first. So 6 minus 2 is 4. So the 4 factorials are going to cancel out, and you're going to do 5 factorial. 5 times 4 is going to be what? 20. 20 times 3 is? 60. 60 times 2 is going to be? Yes. And that will be your final answer. Okay, and then for this one, this is different because the 7 minus 4 is not inside the parenthesis. So you're going to do those separately. And then 3 minus 2 is 1 factorial. Okay, 1 factorial is also 1, just like the 0 factorial. So if we do 7 factorial, oops, over the probability, okay, we get 5,040. 4 factorial is just 4 times 3 times 2. So what's that going to be? 4 times 3 is 12. 12 times 2, 24. So then if we just subtract 50, 40 minus 24, do 50, 40 minus 20.
50, 60.
Yes. And then it's over 1, so be 5016. That will be your final answer. Okay, so if it's in parentheses, you would do that first, and the factorial gets applied to that quantity. And then here we had to do our factorial separate. All right, now we're going to learn about the permutations and the combinations that I mentioned earlier. So a permutation is a selection of a group of objects in which order is important. Okay, so often you'll hear me say like, oh, does order matter? Does order not matter? And this one, your order matters. Okay, and as we go through some of the examples, you're going to see different situations that arise where your order is going to matter. Okay, for instance, if you're picking different positions. So if I just wanted a group of 4 of you and you didn't have any special titles, the order wouldn't matter. But if I wanted a group of 4 of you and wanted to make you president, vice president, secretary, treasurer, then the order would matter. The equation or the formula for n items, so n total items, taken r at a time, so how many you're taking at a time, we can use this equation. Okay, so we're going to find the number of permutations of 7 items taken 3 at a time. And we're going to calculate 7p3, which would be 7 factorial over 7 minus 3 factorial. Okay, or 7 factorial over 4 factorial. So when you think of this, start thinking, oh, this is 7 times 6 times 5 times 4 factorial, because these will cancel. What's 6 times 5?
30.
30. So 30 times 7. 210, right? So the 3 times the 7 is the 21, and then you can put the 0 on it. That's the way you can use your mental math. Okay, for the combination, that is going to be a grouping of items in which order does not matter. Okay, so this is often like a group where you don't have any special titles. It doesn't matter the order that these are going to appear in. Now let's look at this equation. So you still have your n as your total, taking r at a time. Okay, and maybe you guys have heard of the radio show like NPR. Yeah. Okay, so that's how I remember what goes first, your n. So let's look at the equations. They're almost the same. What's the only difference? This one has the r factorial on the bottom, which means you're going to be dividing by something. So before we even calculate this, if we're using the same numbers, 7 and 3, is the combination going to be more or less than the permutation? So if you're dividing by the whole number, right, you're going to end up dividing whatever's on the numerator by something else, which means it's going to get smaller. So if I have 7 divided by, my r is 3, this is 7 minus 3. Okay, well, didn't we just do this part here? It's really like you're doing 210 divided by 3 factorial, right? You could also think of it as, oh, this is 3 factorial, this is 4 factorial. We just did 7 times 6 times 5 times 4 factorial. Three factorial is just going to be what?
6.
It's just going to be 6. So then aren't these going to cancel out? So I just have 7 times 5, which is 35. All right, so I said compare the results. We already talked about that. Will there always be more options with permutations? And then why or why not? So when it's asking you, are there always going to be more options with permutations? This means when you have the same when you have the same values for N and R. Okay, so again, let's go back to the equation. We said this part is the same. The only difference is whatever you get here is going to be divided by your R value. Anytime you're doing division, as long as it's a value over 1, isn't the number going to get smaller? Yeah. Okay, and this won't be ever a fraction because you have to use the natural numbers. It's only for natural numbers. It's not for fractions. Okay, so yeah, this is always going to be the case. From a standpoint of the equation, when you divide, since the combination is always going to be divided by R factorial, it will make a smaller value. Also, just think about the order. If the order does matter, you're going to have more options. Okay, and again, that's with your same value for N and your R. So for our next example, we're going to determine if we're going to use a permutation or combination, then solve. I'm going to show you how you can do the permutation and combination on your calculator. So the first way says, how many ways can a student government select a president, vice president, secretary, and treasurer from a group of 6 people? So there are 6 people total. So that lets me know that my N value is going to be 6. Out of the group of 6, how many people am I choosing? 4. Okay, so it's 6 people. I'm choosing for president, vice president, secretary, and treasurer. Okay, is my order going to matter here? So if I'm choosing 4 people and assigning them roles, I can choose 4 people, and if I chose Joe, Max, Ethan, and Kate, right? I can make Kate president, Ethan vice president, Max the secretary, Joe the treasurer. That would be one order. But then couldn't I also flip it around? Make Joe the president, Max the vice president, Ethan the secretary, and Kate the treasurer. Wouldn't that be a whole different option? Okay, so then your order is going to matter. Okay, so if your order matters, we are going to use the permutation. So out of 6 choices, 6 total people, we are going to take 4 of them where the order matters. Sorry, it's going to be P because your order matters. And then I'm going to show you how you can do this on your calculator. So you may have noticed when we arrowed over to probability, we did have something that said NPR and NCR. You have to type in the N first. So on your blank screen, you can type in 6, go to math, arrow over to probability, and then type in your R. Bada bing, bada boom. And then it does the factorials for you. Okay, so there'd be 360 different ways out of 6 people that I could choose these 4 different roles. Okay, so anytime you have a role, if you're assigning roles or you're assigning positions, the order is going to matter. Okay, so order matters when you are assigning different roles. rows, okay, or positions. All right, for B, it says there are 12 different colored cubes in a bag. So you have 12 cubes. How many ways can Randall draw a set of 4 from the bag? So your n value, there's 12 cubes altogether. Okay, he's drawing a set of 4 of them. But notice the language here. It says how many ways can he draw a set of 4? So the set of 4 is a group. The group of 4 means that your order is not going to matter. So it doesn't matter the order that he pulls them out in. We want to know the different sets. So order does not matter, okay, when it's the whole group. So we can do 12. And out of those 12, we are going to choose a set of 4. So it's a group of 4. There's no sequence is a way to think of it. It doesn't matter the way that you're pulling them out of the bag. And then I can do 12. Now I'm going to use my NCR, choosing 4 of the 12. And then I should get 495. Okay, for C, how many ways can a stylist arrange 5 of 8 vases from left to right in a store display? So she's arranging 5 of 8 vases. So you have 8 vases total. You're arranging 5 of them. They're going from left to right. What do we think? Does order matter? Yes. Because she can arrange them in different ways. So if she's arranging them from left to right in the display, okay, then your order is going to matter. If it just said how many ways can she choose 5 of the 8 vases to display, that would be different. Because it's left to right, your order is going to matter. Okay, so we're going to do 8 of 5. And there really is another way you can think of this. We can think of this like our password as well. Remember how before with the password, I said, okay, you have these blank spaces, so you have 5 vases to display. If you have 8 choices, you have 8 choices for being the furthest to the left. How many choices would you have for the next one?
7.
Yep. And then it would continue to decrease. So if you did 8 times 7 times 6 times 5 times 4, this is what you get. So you can think of it this way too. You can think of it in terms of the display. All right. For part D, it says Randy can choose 3 of the following toppings for his burger. So he can choose 3 out of bacon, tomatoes, lettuce, onions, and mushrooms. Okay, so how many total choices does he have? 5. Okay, so my N value is 5. He's going to pick 3 of them. So my R value is going to be 3. Does the order matter here? No. Think about when you order at a restaurant, right? If you tell them what 3 things you want, bacon, tomatoes, lettuce, does it matter the order that you're telling him? Is that going to come out in a different way based on what you say?
Specifically in this order.
That would be something that you could say. Good luck with that.
I know some people spit in my meal.
Well, hopefully not. That would be a health code violation. But I'm saying they'd probably forget to do it. Okay, so you'd have 5 options. You're choosing 3 of them. And then how many different ways would you be able to arrange them? 10. So yeah, it's not like if you ordered the bacon, lettuce, and tomato that you would count it differently if it went bacon, tomato, lettuce, and then lettuce, tomato, bacon. We wouldn't count those as two different options.
It's really good right now.
I know. That. Those would be my three choices. Would be that. Okay, for D or E, how many ways can you choose a 4-digit password if no digits can be repeated? So again, there's a couple different ways you can do this, but anytime you have a password, does your order matter? Think about your lock screen, right? If your password is 1234 and you enter 4321, is your phone gonna let you in? No. Okay, so yes, your order matters. So how many options do you have of your digits? 10. So your N is 10. Your R is 4. So you could do 10 and then P4. Or you could do what we did before. If it's a 4-digit password, right? You have 10 options. And it says it can't be repeated. So 9 times 8 times 7. Now, if they could be repeated, you'd have to do the 10 times 10 times 10. And did you guys get 5,040? Good. Hooray. All right, and then the last one. Bree has to select 5 photos from a box of 25 to use in the yearbook. How many ways can she select 5 photos? Now, again, it's how many ways can she choose 5 of the 25. It's not talking about a layout here. It's just out of the group of 25, she's picking 5. So that means your order does not matter. Okay, so out of the 25, she's just going to choose 5 of them. And she still has a lot of options. So she has 53,130 ways that she can choose a group of 5. All right. I am going to give you some time to work on your homework today, but we're also going to look at one of our quizzes that we haven't gone over yet. Okay. For 7-1, and you guys can see kind of how quick some of these are. You're going to do 1 through 15. The next set is just going to be the odds.